Carrie Brausieck. I am Catherine Wells, and I will start sharing my screen right now so that we can start our presentation. Thank you all very much for coming via your living rooms or your kitchen or your back porch. This is Climate Resilience for Rural Properties. It's co-hosted with the Camano Wildlife Habitat Project and the Snohomish Conservation District. This is how we used to gather for these things. This is the blue building on Camano Island, for those of you who are familiar. And this was not one of our Camano Wildlife Habitat Project gatherings, but you recognize that orange carpet. And we used to be in a room together, but now we are sitting in front of our computers with our various animals around us who are disrupting our work. And we lose a little bit of the connection that we used to have. However, we will reinsert some of that tonight. You can ask questions, and I will get into how to do that in just a moment. So, welcome. For those of you who don't know me, my name is Catherine Wells. I'm the Communications Program Manager for Snohomish Conservation District, and I'm also a habitat steward with the Camano Wildlife Habitat Project. So, how to interact with us. Tonight, we will be mostly presenting to you. All of our audio lines are muted, so we can't hear you. Hopefully, you can hear us. Our panelists will be able to share our videos, and we'll be able to speak. But you can interact with us by asking questions. So down in the bottom of your Zoom screen, there's a Q&A, and you can click on that. It'll ask a question. The group will not see it. The rest of the attendees will not see it until it has been answered. And we will answer those live. Carrie has inserted points in her presentation where she will take questions. So I'll monitor all the questions coming in, and we'll answer them in bunches as we go through the presentation and at the end. If you have trouble, let me know by email. You can try chat. So down by the Q&A, you'll also see a chat button, and you can click on that and say, hey, I'm having trouble, I can't hear you, something like that. We'll try to fix whatever we can. Bandwidth is not something that we can fix, so but we'll do our best. And this will be recorded. It is being recorded, and we'll have it saved to the Snohomish Conservation District YouTube channel, and that link will be on the Camano Wildlife Habitat Project's website. Pardon me. If you're really having trouble, email me. I will be trying to watch my email at the same time. Let me tell you first a little bit about the Camano Wildlife Habitat Project. It is a volunteer-run organization sponsored by the Friends of Camano Island Parks, and it's a part of a larger program run by the National Wildlife Federation about backyard wildlife habitats, certified wildlife habitats. Our motto is an island in harmony with nature, 1 yard at a time. And what does that mean? It means that what we do is we try to encourage people who have properties of any size, whether they're 10-acre properties, 40-acre properties, or a little 1/10 of an acre lot, or maybe you even just have a balcony, but to provide food, water, cover, and places to raise young for birds, butterflies, bees, other wildlife. Basically, what we can try to do is create habitat corridors across the developed landscape. So we don't just have patches of park here and patches of wild space there, but we've got an interconnection between those wild spaces and our developed areas where animals can move and find what they need to thrive. We are a volunteer organization, and we offer community education programs, usually in person, but the world has changed, so we hope to get back to that as soon as we can. And then we also offer a backyard habitat garden tour, which sadly, again, because the world has changed, it is canceled for this year. But stay in touch with us via our website, and we hope to get back to normalcy as soon as we can, and for the garden tour, hopefully next year. If you do provide food, water, cover, and places to raise young for the wildlife on your property, you can fill out a checklist and get a sign saying that you are a certified wildlife habitat. For those of you who live On Camano Island, you can opt for this beautiful sign that one of our volunteers created, or this is the National Wildlife Federation sign, and it tells your neighbors what you're doing. If you have a slightly messy yard because you're letting the dead-headed flowers stay on to provide seeds for birds, it helps explain why. You're not just a lazy gardener, you're actually providing habitat. Conservation districts. The Snohomish Conservation District is one of many conservation districts across the state. These are the ones that circle Puget Sound. Snohomish Conservation District serves Camano Island. Whidbey Island Conservation District serves Whidbey Island. So wherever you are, you have a conservation district. What does that mean for you? We partner with private landowners and even renters to voluntarily take actions to keep our air, water, and soil healthy. We are community-based hubs of natural resources expertise. We're staffed by locals who understand the needs of the landscape and our fellow community members that we serve. We are voluntary and non-regulatory, and we're funded by local, state, and federal funds. We offer personalized advice for your property and for the goals for your property. It includes engineering and site plans, youth and adult education, websites and how-to videos. We offer habitat restoration and floodplain management, farm planning, urban agriculture, and stormwater solutions. We also, for our adult education right now, everything is virtual. You can go to our events calendar and see what's coming up, and I'll let you know right now that on May 28th, we have a Living with Beavers webinar that you're welcome to join in, even if you don't live in the Snohomish River Basin. If we do have over 100 people sign up, then we will record the webinar and you can access it later. We need to give priority to some people in some priority watersheds, but it's a fantastic talk by one of our habitat restoration specialists who is an expert in beavers. Now, let me start with our webinar, Climate Resilience for Rural Properties. Carrie Brausieck is going to be presenting tonight. She is one of our small farm resource planners. She specializes in agroforestry, carbon sequestration, climate resilience, and regenerative agriculture. She finds ways to improve the ecological function and carbon capturing capabilities of farms and rural properties. Please help me welcome Carrie, and we'll get our slides all set up so that she can share her screen.
All right, thank you, Catherine. So let me get this shared here. All right, how's that? Does that look good? Okay. All right, well, thanks. That actually was a great introduction. That was a good introduction for me too, to learn more about this wildlife group. And so a lot of what I'm gonna talk about, I really like Catherine's bit about creating these wildlife corridors across the landscape, and a lot of what I'm going to talk about really plays into some of that as well, some of the practices that I'm going to highlight. So very cool. So tonight we're going to talk about climate change resilience, and just to give you guys a little kind of flow of the talk here, I am going to start with some climate change data, and many of you may have been exposed to this already. You may have already heard talks or read articles, but I just want to make sure we're all on the same page. So I'm going to talk about some of the latest data, the latest predictions, and some of the impacts that we're looking at right now. And then move into that resilience, the different strategies such as mitigation strategies and adaptation strategies, and then what we can all be doing on our own individual landscapes. And as Catherine said, I will pause every now and then to address any questions that might come up as well. So in 2018, the International Panel on Climate Change came out with one of their latest reports on sort of the state of global climate change and the latest predictions and data and modeling and all of that. And then in 2019, they followed up with some more reports. and many of you may have been exposed to that. You may have heard about them on the news. So in response to that, the University of Washington Climate Impact Group came out with their own report called No Time to Waste. And this is a great report because it takes that huge document of hundreds and hundreds of pages and it sort of synthesizes it down into some more digestible material. And then it expresses what those impacts and what the meaning of that report is for Washington State specifically. So it takes that big international report and narrows it down into our neck of the woods and makes it local for us. So if you're interested in learning some of the latest data, the latest predictions, this is a great report to go to, and it's the University of Washington Climate Impact Group. That is the link there, but if you just type into your search bar CIG, No Time to Waste, this report is going to readily come up. And this is just a great resource overall for local climate data and some reports on how climate change is impacting our local wildlife, local forests, agriculture, all different types of things. So a great resource. If you haven't checked out this group, it's definitely worth getting on their website and checking them out. And many of you may have heard them speak. They do a lot of public speaking at many different events and for different organizations throughout the area as well. So many of you may have run across them already. So just kind of taking some of the data out of that No Time to Waste report, just to get us all on the same page and to sort of build a starting point here. So these are some of the latest predictions for for the trends that we see our climate moving into in the next few decades. And what this is saying, I do want to give a caveat here. What I am not saying is that from this day forth, all our winters are going to be warmer, or, you know, we're going to have these warm, dry summers all the time. The climate is cyclical, it goes through cycles, and we will continue to have years where we have very cold winters and we get huge snowpacks. We will continue to have years where we have a rainy, cooler summer. What this is expressing is this is just the trends overall, long term. Our climate is moving towards these types of trends. So as we move into the next few decades, this is sort of the pattern that our climate is going to start to take more often than not. So we're looking at warmer winters overall and lower snowpacks. We're still probably going to get a decent amount of precipitation in the winters. That precipitation is just going to be more in the form of rain. So we have many river systems that rely on the snow and these big snowpacks that we develop in our cascades throughout the winter months. And so without those snowpacks and with more rain coming down in the winter, we're looking at higher stream flows in the winter months. And that increases the potential for floods during the winter months as well. Earlier peak stream flows in the spring, if those snowpacks that do accumulate melt off earlier and things like that, we're looking at potential for early spring floods as well. And then late summer flows decreasing. So without that snowpack, without that feed of water into our stream and river systems, those flows in our rivers could look pretty low as we get into the later summer months. Of course, we are looking at sea level rise, and it's estimated at about 1.4 feet by 2100. That is also variable. It depends on where you live along the Washington coast. There will be pluses and minuses to this number depending on where you're at. And we're looking at those dry years that we do get, they're just going to be amplified. They're just going to be that much drier. And those warmer, drier summers are going to be, we're going to get those more frequently. And really, a good sort of benchmark for what our summers might start to feel like more often would be that summer of 2015. If we can all think back to that summer and what that felt like, it was pretty warm and pretty dry for quite a long time. I think we did have a few days where we got some cloud cover, and I remember getting all excited, and it just never rained. So that's kind of, if you can think back to that summer, that's kind of what we're talking about. That gives you sort of a mental image of the types of summers that we might start to see more frequently. And then there are impacts to our ecosystems, to our environments, to our wildlife, to our own landscapes. So looking at impacts to our forests, and many of you may already be witnessing some of these impacts, we're looking at expansion or dieback of certain species, still learning and collecting a lot of data on how that's going to play out and what species are going to be most affected. Insect and disease outbreaks could become more frequent. Drought stress is definitely something we're looking at. It's something that's already been seen with some of our tree species. Western red cedar has been one that has been suffering with drought stress in certain areas. Western hemlock is another one that is experiencing some dieback. And there's a lot of, it's suspected that drought stress plays a huge role with some of the issues that some of these species are having. And as those species, you know, if they get drought stress, it weakens them, and then they can get a secondary issue happening. Maybe it's a pest outbreak because they've been weakened, or maybe it's a fungal infection in their root systems or things like that, and then the trees are killed off. Changes in species composition with our forests. So, you know, maybe if we're experiencing drought stress with our Western red cedar, for example, we'll use that tree as an example. That tree, as we move through the next few decades, that species may start to die back in our forests, and we may not see it as frequently. Individualistic species range shifts. So it may be that Western red cedar dies back in our area here, but it moves north, or it stays, you know, in northern forests in BC, Canada, for example, or it moves upslope or something like that. And then potential species extinction. It could be that, you know, Western red cedar just dies out in our forests and we don't have it after, you know, by the year 2050 or something. We're just learning and just starting to feel some of these impacts with some of our tree species. And then there's impacts to wildlife. Obviously, our salmon species really struggle. We have lots of issues already with our salmon populations, with loss of habitat and with pollution and all of those pressures that our salmon face. And then, unfortunately, climate change is not going to help the situation much. So with increasing temperatures, with lower summer stream flows and things like that, we're really looking at, you know, substantial increases in temperature, in water temperatures. And our salmon species are cold water species. They like the water cold. And of course, this can increase disease pressure, it can increase hypoxia. And what hypoxia is that cold water tends to hold more oxygen. As water warms up, it holds less oxygen. And then it becomes hard for some of these species to get the oxygen that they need in colder, from those warmer waters. We're looking at marine heat waves off our coast, and we've already had some of these. We actually had a mild one last year that did have some mild impacts on some of our fish species. I don't know if any of you heard about the blob, which was a big sort of marine heat event in the Pacific a few years ago, and that really had some impact on quite a few species. So again, marine heat waves, creating these hypoxic kind of conditions and then having impacts on food sources for our marine mammals. Lower snowpack, so we have quite a few species in our Cascade Mountains that rely on the snowpack for their survival. I'm sure many of you have been hiking in the Cascades and have seen that darling little rodent type creature called the pika, and they whistle to each other. So they really rely on the snowpack to insulate themselves during the winter months. And we also have a Cascades frog that does the same thing. It relies on that snowpack for insulation during the winter months. And when we have years where that snowpack is reduced, these species can have a hard time making it through the winter. And then we also have some mismatches that we've been noticing in sort of when things will start to bloom and when pollinators will come out to, you know, match up with those certain blooms. So there's been some mismatching there that's been noticed, which can make it hard on pollinators. It can make it hard on getting things pollinated. So these are some other impacts. This is just an example of some of the impacts that our wildlife face with a changing climate. And then we have human impacts as well, heat-related illnesses. We all remember the smoke that was here in our area recently, and you know, there were warnings that we shouldn't be going outside and those types of things. These warmer and drier summers and drought conditions could lead to decreases in certain crops and certain crop yields for some of the crops we grow in our area. And then there's recreation loss, right? With lower snowpack, it's harder to go skiing or snowshoeing. With decreased stream flows in the summer, it can be harder to go fishing or swimming perhaps in certain areas. And then there's those increasing costs as well for infrastructure, for things like stormwater management, flood protection along our coasts, and all types of things. So this is not to cast doom and gloom or get everyone depressed. I just want to sort of set a groundwork of where we're at and where we're starting from so we can start to talk about resiliency and move into sort of those positive steps that we can all take, right? We know these changes are coming. We know we're experiencing some impacts. We've all felt some of these impacts, whether it's you've seen some of the trees dying off, or you remember the smoke, or whatever it is. So just setting that basis so that we can now talk about those proactive things that we can all be doing moving forward. So I can pause here really quick for some questions if they've come up, and if not, we can move along.
We have a question.
Okay.
Do you know of any of the specific pollinator bloom time mismatches?
I don't have any specifics. No, I don't, not off the top of my head. I know that they've been looking at spring bloom times shifting and in general being about 2 weeks earlier than they've normally been. And then if that happens to match up with certain weather events like cooler weather, you might not get the pollinators coming out. So I know of some general information. I don't know of any specific species that have been mismatched, but I know that this is an area that's being looked at and studied at the moment.
Okay, I'm not seeing any more questions right now.
Okay.
So I think we can continue on. Continue sending in your questions as they come up, and we'll save them up for the next little question break.
Great. So what can we do? You know, there's a lot of economic and social and health related and ecological things that we can do to combat climate change. And for this talk, we're really going to focus on the landscape, right? On our landscapes, on those sort of ecological things that we can do to create these resilient landscapes and wildlife corridors and things like that. So really the focus when we're thinking about our landscapes and what we can do, we really want to focus on how we build resiliency into our ecological systems, whether that's a backyard that you may have, whether that's a small farm, maybe you own some forest land, whatever type of landscape you interact with. And this could even be a local park that you like to frequent. Or this could be some open space within an urban area, looking at street trees or things like that. Any of those landscapes that we're interacting with, that we're nurturing in some way, we want to start focusing on how we can build resiliency into these landscapes. And when we're talking about climate change, there's a really simple definition here for what resiliency means. And really, it's pretty simple. It's just strengthening the ability of systems to withstand and respond to changes in the Earth's climate. And those could be human systems, and those can be ecological systems. And when we're looking at ways to build resiliency, when we're looking at strategies with dealing with climate change, there are really sort of these two bowls of strategies, or these two camps of strategies, if you will. There are mitigation strategies and there are adaptation strategies. Mitigation strategies really have to do with greenhouse gas emissions. They're very focused on those, right? So that's either reducing the amount of greenhouse gases that we're putting into the atmosphere, or it is taking those greenhouse gases that exist in the atmosphere and finding a way to sequester or to suck those greenhouse gases back out of the atmosphere and store them somewhere, whether that's through technology or whether that's through nature-based solutions or things like that. There are different opportunities for that type of mitigation as well. So those are really mitigation strategies, and there's all kinds of different, things that we can do around mitigation. And then there are adaptation strategies. And what adaptation strategies are looking at is they're kind of saying, okay, we know that, these certain changes are coming our way. We know that we're probably going to face certain impacts. Maybe we're already witnessing some of those impacts. So with that knowledge that we have, how are we going to adapt to that, right? What are we going to do? How are we going to change some of our systems? That might be rebuilding some of our infrastructure. That might be reimagining some of our food systems or some of the crops we grow. So those types of things, how we think we can take our systems, our landscapes, our social systems, whatever it is, and how we can adapt to those changes that we know are coming. I do want to say too, it's been interesting because I've sort of been involved with climate change for many years, and probably earlier on, like 10 years ago, maybe even 5 years ago, a lot of the focus was around mitigation strategies. How are we going to stop emitting greenhouse gases, sort of keep it in the ground campaigns and 350.org campaigns, and a lot of talk about, about reducing emissions in the first place, research into technology to sequester emissions back out of the atmosphere. But in the last 10 years, and especially in the last 5 years, a lot of the focus, a lot of the resources, a lot of the money and energy and things like that have really shifted to the adaptation strategies. I know that city governments, county governments, state governments, national institutions, I know like NOAA, for example, they're really putting most of their time, energy, and resources into these adaptation strategies at this point. And that's because at this point, we kind of know that there are certain changes that are built into the system, right? We know that we're going to see certain things in the next several generations. And so really there's a lot of focus now these days on, okay, we know this is coming. How are we going to adapt to this? And how are we going to get ready for those changes so that when they do start to come more and more, we're not reactive. We're not trying to play catch up. So all of this can be very overwhelming, right? I'm sure we've all, that you've all heard things on the news or read articles or even read maybe some scientific research or whatever it is on climate change. And even when we're talking about solutions, right, which should be rather positive, solutions can be very overwhelming. There are tons of solutions out there. There's all kinds of things you can get involved in. There's always some new article or some new research about this is the best thing for climate change, or that's the best thing for climate change. And it can be very overwhelming and very hard to keep up, and really hard to know what to do, and to know what to put your time and energy into. We're all very busy. We all have busy lives, and we all have limited time and resources. So there are some interesting resources out there to kind of key in on some of the things we can personally do that would kind of get us the biggest bang for our buck, if you will, right? That can make us the most effective with the limited time and resources we do have to devote to this. Maybe some of you have tons of time to devote to this, and that's amazing. Others don't. So there are a lot of resources out there that can really help you focus in on, okay, I want to be proactive with this. Where can I put my energy and attention to be the most effective? This, for example, Project Drawdown, which came out in 2017 and was really launched at that time, was launched by Paul Hawken. Many of you may be familiar with him. Many of you may have heard of Project Drawdown. If you have not, it's a cool website to check out. And what this pie chart here represents is it looks overwhelming, right? There's a lot of solutions here. These are all solutions to climate change. What these folks did is they went out and they researched all these different types of actions that can be taken. And then they did cost benefit analysis. They did, all kinds of different data collecting to come up with this pie chart. And you can get on their website and you can kind of peruse all these different solutions. And they're really cool. And you can look at how much carbon they sequester, and you can look at all kinds of data about these solutions. And so there's a lot of different options here, depending on your community, depending on where you live and what might be appropriate to your area. Most of us may not be working on tropical forests, for example, but a really interesting website to check out if you want to learn more about that. But what I want to point out about this is that while this looks overwhelming and it looks like there's tons of different solutions here, what we can start to see is that we can start to pick out themes. And so, for example, I'm going to focus on food. So there's all these different pieces of this pie. I wish I had, can you guys see my mouse? I don't know. Maybe Catherine can let me know.
Yes, we can.
Okay. Yeah, great. So we have all these pieces of the pie, but we can clearly see that some of these pieces are bigger than others, right? And so we have reduced food waste, for example, and that might be something that we can all do quite easily. And that's actually a pretty big piece of this pie. So if you were to just pick one thing, reducing food waste could be quite beneficial. Then if we combined that to reducing food waste and focusing on a plant-rich diet, I'm not saying don't go out, don't eat meat anymore, but maybe we eat more vegetables than we usually would, or whatever it is. We can have quite a big impact when we add these two pieces together. That's a huge piece of this overall pie here. And then we notice that they have a red color. And then we notice there are all these other red colors, and these all have to do with food, right? So this is about how we consume food. This is how, these little pieces over here are about how we produce food. And so we can see here we have silvopasture, we have regenerative agriculture, we have tropical staple trees, we have intercropping and conservation agriculture, we have multi-strata agroforestry, So we can really see now that there's this real sort of theme of food coming forward that actually really makes up this huge piece of the pie. So not only how we consume food, but also how food is produced. And once we start sort of putting that puzzle together, we can really have a huge impact by maybe just focusing on where we buy our food and how we consume our food. So the major themes, I talked about that a little bit. So we can see food and agriculture is one of those major themes. We can see land sinks. The green color in that pie chart was mostly all about forests and trees. There's the theme of transportation, of energy, social issues, industry, lots of different themes. But for this talk, I kind of want to take the two themes that you see highlighted there, food and agriculture. And what I'm really getting at here is land use, right? How we produce our food and really kind of sort of our local food, right? Some of us may have farms, some of us may have garden beds. So kind of getting at that. And then getting at these land sinks or really trees and forests. Because I think in our environment, in our locale, in sort of our culture here, these are some of the things that we can pretty easily do on a one-on-one basis to be pretty effective when it comes to climate change and building that resiliency. These are also two areas where we can be very effective at building resiliency into our landscapes. So when we're talking about building resiliency, if you get nothing else out of this talk, if you go out after this and totally brain dump everything, I'm fine with that. The main thing I want you to remember, if you remember nothing else, is diversity equals resiliency. That's the mantra for this talk. Diversity equals resiliency. And I want you to be thinking in those terms when you go out and you interact with your landscapes. And like I said, whether that's your local park, whether that's your backyard, whether that's your small farm or some forest land you have, whatever it is, next time you go out and interact with these landscapes, be thinking in those terms. Really take a good look around at the diversity that exists and the opportunity for more diversity. And that's diversity in plants, not only in species, but in function and in structure. And that will then, of course, nurture that diversity in wildlife, whether it's insects or birds or small mammals or whatever it is, right? So diversity equals resiliency. And I will mention this theme as we move forward in more slides as well. So I can take a quick pause here. If there's any questions that have come up.
Not yet.
Okay.
We'll watch for.
All right.
Nope, I think not. Okay.
I will move on then. So really working off those two themes that I highlighted, because we're focusing on building diversities in our landscapes. Really the first one to address is soil and the power of soil. Soil, really to use sort of some relevant sort of speak for today, if we can think about the soil as an immune system, right? So if we eat a healthy diet, if we exercise, if we get enough rest, our immune systems are going to be healthy. And if a virus comes along, or if an illness comes along, we may get sick, but we will probably, do a pretty good job at fighting off that illness and recovering, right? Because we've stayed healthy and we've developed a good, healthy immune system. And that's kind of how I want you to think about the soil. The soil really, for a landscape, for any kind of ecological system, really can be the immune system of that ecology, of that landscape. Soils are very powerful, and the way that we treat soils can have beneficial effects or it can have negative effects. It can build resiliency into a system or it can take resiliency away. So how we deal with our soils is very, very important, and that's where I want to start. And this graphic here shows, obviously agriculture is a sector that uses soils, right? It relies on soil to do what it does, to produce the products that it produces. And we can see here, this is, I think, a 2018 snapshot. And these are different sectors of our economy. And this is the percentage of greenhouse gas emissions that these sectors contribute to within the United States. And we see agriculture there at 9%. Now, this is not to pick on agriculture. This is actually a good number. This is a number that's improving. Agriculture, several years ago was at like 13% or 15%. So things with agriculture are moving in the right direction. We see that number, that 9% there, we see that number going down. And the reason that's going down is because people, farmers, and all those entities that work with agriculture are starting to look at soil health and really focus on soil and how soils are being managed, and really sort of shifting that focus and shifting that narrative and shifting that reality of soils emitting greenhouse gases because of certain management to the power of soils to sequester or to suck in those greenhouse gases and to store them long term. So healthy soil equals immunity. Like I said, what we really want to focus on with soil is the health of the soil. And what does healthy soil mean, right? What does that mean? So healthy soils have some general characteristics, right? We can go out on the landscape and we can dig around in our soil and we can make some initial assessments about whether it's healthy or not. So healthy soils tend to resist erosion, and they tend to resist excess loss of nutrients. Healthy soils are pretty good about holding nutrients long term and making those available in sort of a slow release type of system to plant communities. So, it's not typical to see a good healthy soil sort of blowing away in the wind, or a good healthy soil sort of running off in surface water, or things like that. Healthy soils are really spongy, they're kind of sticky, they kind of glom together really well. So yeah, one of the characteristics of a good healthy soil. Healthy soils nurture high populations of biological organisms. Diversity equaling resiliency in our soils. Diversity of the life in our soils equaling the health and the resiliency of that soil. There are thousands and thousands of bacteria and fungi and protozoa and macro and microinvertebrates and moles and earthworms and all kinds of beetles and all kinds of things that live within and interact directly with the soil profile. And all of those things are incredibly important for the health of that soil. That rich earthy smell, especially in our environment, in our climate, our soils tend to have that really nice, and it's sort of, it's sort of intuitive almost, that sort of, when you've like walked into the forest and you smell that humusy kind of sweet kind of soil smell of the forest, or when you're digging in your garden and you've got this great, rich, gorgeous soil, and it's just got that, sort of intuitive, healthy smell to it. And you kind of know when a soil's off, right? It might smell funky, it might not look great, So that rich, earthy smell. I know it's kind of subjective, but it's kind of an intuitive thing. Healthy soils do not require increased inputs for high yields of crops or flowers or shrubs or whatever it is we're trying to grow, or a lawn. A good healthy soil is going to have these nutrient cycling capabilities. So you really, and that's through this interaction of roots and these biological organisms that I'm talking about. The more life you have in your soil, the less sort of inputs you're going to generally need in a good, healthy soil. And healthy soils produce high quality crops or shrubs or lawn or trees or whatever it is, whatever we are wanting to grow on our landscapes. If we start with a good, healthy soil, a good, resilient soil, all of those things we want to grow are going to be robust, they're going to be healthy, and they're going to be resilient. So how do we manage soil then? How can we manage soil so that we're not emitting greenhouse gases, so that we're sequestering greenhouse gases, so we're storing greenhouse gases, and so we're building that resiliency? So really we can look to nature, especially in our ecosystem here. Nature does a beautiful job at creating these amazing healthy soils like I just described. And nature does this with a few techniques, right? So one of the ways that nature produces this amazing soil is nature tends to keep soil really well protected. You don't go out and see huge swaths of bare soil on a regular basis. That's kind of a rarity in nature, especially in our ecosystem. I mean, yes, we could have a landslide, there could be an event or something like that that would create a lot of bare soil. But in general terms, within our ecosystem, soils are very well protected within nature. Nature uses polycultures. Again, that idea of diversity creating resiliency, right? Nature takes many species and through competition, they create these symbiotic cooperative communities. Everything kind of finds its niche. And you get these amazing, complex, symbiotic ecosystems with a lot of diversity in them. Nature doesn't tend to go out and plant a big field of pumpkins or go out and have a big lawn with 2 types of grass or go out and plant a big, stand of Doug fir. Lots of diversity within a natural system. Nature does not tend to till the soil. Nature doesn't tend to dig up the soil on a regular basis and turn it upside down. The way soil is still tilled within natural systems, but it's the reliance on that biodiversity within the soil, on those organisms, on all that life, and on the root structures of plants, all of that interaction together, those root structures digging way down deep into the soil, especially with perennial plants, all that biodiversity of life in there, that tills up the soil. That cycles that soil from deep down in the soil profile and from the dead material on top, and it, breaks it down and it interchanges it, and it creates this cycle of fertility that begins to occur in these natural soils. We tend not to manage our soils that way. We tend to dig up our soils a lot, right? A lot of tillage, a lot of digging. And I'm not saying you never dig your soil. I understand, we're going to landscape sometimes, we're going to plant a tree, we're going to create garden beds or whatever it is. But really focusing on limiting our tillage, right? Not tilling as often as we do. Because when we till, especially if we have systems where we're tilling sort of on an annual basis or, even biannually, or we're tilling pretty regularly, or digging up that soil pretty regularly, that's very destructive to this great soil structure, to these healthy soil aspects that I talked about. And it's also very damaging to that diversity of organisms within the soil. We're learning more and more that the more you dig in the soil and the more you sort of disturb that soil, the more damage is caused to all that diversity of life that exists within that soil profile. We tend to focus, or we tend to plant in sort of low diversity, and we tend to sort of favor low diversity systems. in many forms, right? Whether that's on a golf course, or whether that's on a farmland, or whether that's in maybe some forest stands, or whether that's in our backyard in just our lawn, right? So low diversity monocultures, you know, we kind of want to get our mindset away from those terms, from that style of thinking. Because we take that diversity out, because we tend to create systems where they're lower in diversity and they're less complex, then we have to come back in and we have to add things that nature would have probably provided if the diversity still existed. And that might be that we have to add in those fertilizers, or maybe we have to use some pesticides sometimes, because those ecosystem services aren't there anymore, because the diversity isn't there anymore, or because the life isn't there in the soil. And then we tend not to do a great job at protecting soil. We do tend to have, you know, a lot of bare soil in our systems. Not that bare soil is always bad. There's, you know, definitely times when bare soil is fine to have. But in general, you know, really focusing on that protection of the soil. So we want to manage soil like nature, right? We want to dig as little as possible, till as little as possible. There are all types, if we're farming, there are all types of methods now that reduce the amount of tillage that we can do, or there are no-till systems sometimes that work for people, depending on what kind of farming you're doing. There are methods now even in our own backyard garden beds that are like no-dig gardening and things like that, right? So there's always ways that we can think about reducing that disturbance of the soil as much as possible. And then limiting bare soil, right? So if we do have a garden bed, or if, you know, if we have planted something or whatever, maybe putting some mulch down, maybe putting some straw down, maybe planting in a diverse canopy or diverse leaf structures, so that those are protecting the soil. Maybe letting, you know, when the trees shed their leaves in the fall, maybe it's okay to leave some of those leaves on the ground and not have to haul them off and take them to the yard waste. You know, those types of things, leaving some of that cover on the soil, making sure soil is generally covered and protected from the elements. And then again, that word diversity, adding diversity into our systems. Diversity in what we add into our soil profiles equals resiliency to our whole system. And diversity, you know, it can be in annual plants that we plant, but really one of the most effective things for building resiliency on a landscape that we can do is focus on putting perennials into the landscape. Again, you know, lawns are kind of perennial. We're not tilling our lawns all the time, but we can think about diversity in a lawn, for example. Maybe we let some clover come in, maybe some violets move in, maybe we have plantain in there, maybe we have 5 or 6 different grass species within our lawn. There's a lot of ways to add diversity into a lawn space even, right? Or even into our garden beds. You know, a lot of raised garden beds, for example, you tend to go in there and plant your annual vegetables. There's ways to reimagine those spaces to work in some perennials, to keep that soil covered, to think about the diversity that you're planting in that bed. You know, are you planting rows of lettuce, and then over here you're planting, you know, your cauliflower, and then over here you're planting your beans? Can you mix those together a little better? Can you focus on companion planting, right? All of these ways to think about diversity, and then really starting to think about adding perennials into the system. And, you know, that can be into, like I said, our raised garden beds. It can be adding a tree into our yard. It can be even in our farms. If we're row cropping, we can start to add perennials into our farming systems as well. And what's important about perennials, adding resiliency to the landscape, is the perennial root systems add diversity into that soil profile. They add diversity above ground for habitat, for all kinds of wildlife, but they also add diversity below ground. And the thing about perennials is those root systems are in the soil profile and interacting with that soil profile year round. They are living root systems in the soil profile all the time. And that's really important to nurture that biological activity and all those organisms that live in the soil profile. Perennial root systems, living root systems that are going to be in that soil year round, year after year, are very important to building really robust resiliency into soils for so many different reasons. And that's a whole talk in and of itself. And I'm going to try not to get off on a tangent here so that we can move forward. So we've talked about soil, really, and that being sort of the first focus, the first thing that we can really concentrate on when we're thinking about building resiliency to climate change within our landscapes. If we have a healthy soil, if we have a really robust soil, we're going to have that healthy immune system. Our plants are going to be more robust and healthy. Our landscapes are going to be more robust and healthy overall. And just to kind of to illustrate that, you know, look at these photos here, right? Now, I know these are natural systems, but they're diverse systems, right? And we can create systems kind of like this in different ways. Now, what I want you to do is look at these images and imagine a flood or a drought coming along, right? And imagine the impact that that would have on a system like this, okay? We can all kind of visualize that in our mind. And then imagine these systems, okay? Imagine a flood or a drought coming along and hitting some of these systems. And we can kind of really start to visualize and see the resiliency here. We can really visualize the damage that could be done here to a system, to systems like this, versus the damage that could be done to systems like this, right? So a system like this is going to probably sustain damage from a serious event, like a serious drought or a major flood. But it's going to sustain less damage and it's going to recover more readily from that damage, as opposed to a system like this that's maybe a monoculture or doesn't have the diversity or doesn't have the perennials or whatever. A lot of these systems here are going to sort of be decimated and you're going to have to start completely over with some of them. So that's just to give you an idea of what I'm talking about with the soil, with creating that diversity to create that resiliency to some of these changes. And then a little tangent there, started to get off topic. So getting back on topic here, talking about the perennials, talking about getting those into the systems. Perennials are so important for building diversity. They're important for building those wildlife corridors like Catherine mentioned at the very beginning, and all of those types of things within our landscapes. And of course, the apex perennial that we can all talk about here is the tree, right? The tree is the granddaddy of all perennials, with those amazing root systems, with their long lifespans, with all the habitat and the microclimates and all the amazing things that trees do. So I'm going to transition into talking now about trees in our landscapes and our ecosystems. So I can pause quickly.
There is one question. What is your opinion on no-till farming?
So no-till farming it's kind of a conundrum. It's a complex issue. Of course, when we're talking about soil structure and soil health, the less we till, the better. I mean, that just is what it is. You know, the better that soil structure is going to be, the more biological diversity you're going to have in that soil profile. But depending on what we're farming, depending on what we're growing, you know, especially in organic systems, for example, balancing sometimes weed pressures, balancing pest pressures, balancing the way soils are draining in time to plant crops. There's a lot of factors that have to be balanced in certain agricultural systems. And sometimes those systems may require certain amounts of tilling. Systems can be adapted. There are always new techniques. We're always learning more. And we're learning more and more in all of these different systems how to keep working towards reducing our tillage. So right now, I think, you know, I think it can be sort of necessary in certain systems at the moment just to keep production up until we have some better information or some better techniques. But having said that, I definitely think a lot of farms can explore reduced tilling, or there's all kinds of different tillage regimes out there now that really reduce that impact that we have on the soil. So lots of factors in no-till farming. And some farms have gone all the way no-till and do very well with that, depending on the kind of system they have. So it kind of runs the gamut. But I do think, you know, I do think from a soil health perspective, it's always good to be working more and more towards reducing that tillage and reducing that damage. So.
Thank you. That was the only question we had for this break.
Great. I will go on then. So, want to touch on the power of trees. So we kind of, you know, with soil, I kind of touched on that first, if we can remember back to that pie chart, kind of touched on that first theme, right? How we're growing things, and I know that was very focused on food, but how we're growing things. And this can be in our food systems. This can be in our, you know, our flower beds or whatever it is. But really touching on that soil and that theme. And now I kind of want to move on to this theme that from that pie chart of trees and the power of trees. Because that was another thing, when you started taking out those little green pieces of that pie chart and adding them together, there was another big chunk of that pie that started to add up to. So this is another easy thing, especially in our environment, in our communities, in our climate, that we can really do a pretty easy thing that we can interact with to have a pretty big effect with climate change and with building resiliency. So the power of trees. And we hear a lot about trees, especially these days. There's a lot of research going on in trees as what they call a nature-based solution to climate change. And what that means is it's a low-tech, easy thing, something nature does. We're harnessing nature's power and some of the things nature does already to sort of help us sequester carbon back out of the atmosphere. And one of the things that does that so well, other than soil does that really well, is trees. And especially when you add trees into soil, that interaction, that tree sequesters carbon and it uses that carbon to create its biomass, and it holds that carbon in its biomass. And it also sends carbon down into the soil, those huge root structures way down into the soil profile, and stores carbon in the soils long term as well. So trees are incredibly powerful when we're talking about mitigation strategies for climate change. And also when we're talking about adaptation strategies, because of their ability to create microclimates, because of their implications for soil health. When you put a tree in the ground and you get tree root structures in the ground, the implications of that for soil health are vast. That's another whole lecture in and of itself. So trees are incredibly powerful, and for their ability to provide habitat, food, shelter, all kinds of things to wildlife and to us as humans as well. So you hear a lot about trees. You know, there's a lot of research going into trees and their benefits when it comes to climate change. And you know, you hear things like the Amazon is the lungs of the earth, and those types of things. So we really have two things going on when we're talking about trees. We have mature forests, sort of these old growth forests, right? And this includes like the Amazon rainforest. It includes our temperate rainforests here that are still pretty mature and intact, even though, you know, anyway. And the boreal forests that sort of run across Canada and Russia, those big boreal forests way up there in the temperate areas. So all those mature forests, what those really represent when it comes to climate change is they represent this massive storage house of carbon. Like I said, trees store massive amounts of carbon in their biomass. They send massive amounts of carbon down into the soil profile, and in those forest soils, carbon is stored, and this is all long-term storage. So you can imagine that if we cut those forests down, if we lost those forests, if they burn or whatever it is, then we're taking a bad situation with the climate and we're making it that much worse. We're amplifying it because we're gonna lose all that carbon into the atmosphere. So it's very important to be protecting these old mature forests that we already have. The power of young forests is really where you're getting your active carbon sequestration. These young forests that are actively growing, they're actively putting on girth and height and all of that stuff. They're being very active in the soil profile. They're really taking and breathing in a lot of that carbon out of the atmosphere to create this biomass. So really, both of these are important. These old stands and planting new trees and nurturing new forests. So reforestation, afforestation, really important for that sequestration aspect. And so planting trees, we can all plant trees. We can encourage trees to be planted in our parks. We can plant a tree in our backyard. You know, even if we're dealing with a small space, we could plant a little apple tree. There's lots of little dwarf varieties of trees now, right? We can plant, maybe we have big spaces. Maybe some of us have, you know, 10 acres or 20 acres or whatever it is. We can all be planting trees within our environments. And again, that idea of diversity of species and diversity of functions. When you get that diversity of species, these different species have different functions in the environment, and they have different functions when it comes to climate change. And all of this together creates a resilient ecosystem. It creates a resilient landscape. So we have, and I'm going to focus a little bit here on natives for a little bit. So fast growing trees that are going to grow fast, they put on height and stuff pretty quickly, they leaf out really quickly, they mature pretty fast. Those are going to be great for really sucking carbon out of the atmosphere really quickly, right? So those are great to be planting on our landscapes. Trees that are maybe slower growing, they're not going to suck in that carbon as quick, but they may be slower growing, and the slower growing trees also tend to be longer lived, right? So they're going to grow slowly, they're going to sequester carbon more slowly, but over time, as it adds up, they're going to end up storing more carbon and taking in more carbon overall, right? So planting a diversity of these types of trees can be very beneficial across the landscape. Of course, native species, like I said, kind of focusing on natives that are adapted to our climate, adapted to our soils, that our wildlife are adapted to and can make use of, is always a good idea if you have the space or a landscape where you can encourage the planting of our native species. And just to, I wanted to give you guys some numbers just to kind of give you a context, to give you sort of an idea of what we're talking about when we're talking about carbon sequestration. And this is focused on our native species here. Evergreen State College did a project where they came up with some of these estimates for some of our native tree species and their carbon sequestration potential. And we can see sort of that difference in function and carbon sequestration with some of these species. So the red alder, for example, is one of those fast growing trees. It has a shorter lifespan. It grows really fast. It does its thing. It puts on its girth and its height, and it sequesters a lot of carbon really quickly, and then it dies off. So great, you know, for lots of different habitat things, for nurturing the soil, for sequestering carbon. So that's sort of its function. Things like the red alder, like cottonwood, stuff like that. And we can see here the short lifespan of the red alder, and sort of at maturity, it's going to mature faster, the amount of carbon that a red alder would sequester each year. And then we kind of have some of our slower, longer lived trees. And we can see here the western red cedar, average 220-year lifespan. At maturity, now it's going to mature more slowly, so it's going to take longer for that tree to mature and be sequestering this amount of carbon. But when it does, it's sequestering 147 pounds of carbon a year, potentially, and storing that carbon for potentially a long time, right? The big leaf maple, I just had to point this one out. Big leaf maple, one of my favorite trees, a really great picture of the big leaf maple down there in the corner. A long-lived tree, and the carbon sequestration potential of a big leaf maple is phenomenal. The big leaf maple tree is a powerhouse when it comes to carbon sequestration. It's also a powerhouse when it comes to habitat. So many different species use the big leaf maple for food, for habitat, and that's animal species, bird species, insects, but it's also plant life that grows on the big leaf maple. A big leaf maple is almost a whole ecosystem in and of itself. Anyway, so that's enough about big leaf maples. But I have the words climate analogs down here, and I do want to mention that because we are talking about climate change. I did use the western red cedar as an example of a tree that we've seen suffering from drought stress and suffering from some other things, and kind of having some die-offs of this tree in certain areas of our forests. So what climate analogs are, is it's essentially saying, okay, in looking at climate change projections, in the next 20 or 30 years, the climate of Snohomish County may look very similar to the climate of X county in Northern California, for example. That would be a climate analog. We think that Snohomish County in 30 years is going to look like X county in Northern California today, right? So what we can do with that information is we can go to X county in Northern California, and we can see what tree species are growing there and thriving there today. And we can say, there's a really interesting pine that grows here in these forests and really thrives and does well. And so we can take that back to our area, and we can maybe sort of plug in a couple of those pine, sort of as an insurance policy in a way. And there's some debate back and forth as whether this is a good idea or not. Some people are looking at this information. Some people are trying some of this planting kind of stuff with looking at different seed zones and all of those types of things. But when we're looking at planting trees, when we're looking at a changing climate, when we're looking at different species that might die off or some that may thrive better, this is a way to kind of diversify the system and kind of hedge our bets a little bit. So something that's being explored, something that's out there, just wanted, to share that information as well. And then of course, so focusing on our natives, they're amazing. They sequester carbon. They are beneficial to our wildlife. But there's also a lot of non-native trees we can plant as well, right? Urban trees that we can plant that provide habitat and that build resiliency into the landscape. Ginkgo biloba, for example, is a non-native tree that does really, really well in urban environments. It sequesters a lot of carbon. It's very resilient to pollution. It's a very interesting tree, right? There's all kinds of ornamental trees that we might plant on our landscape, or fruit trees, or whatever they are, just depending on what you want in your landscape. But, you know, no matter, you know, we all, of course, we want to stay away from things that might become invasive, right? So we want to shy away from those things. But getting trees in whatever form into our landscape can be very, very beneficial. And then there's agroforestry, right? So we can look at urban spaces for planting trees. We can look at our own backyards. We can look at, and we can look at farmlands, right? So agroforestry is something being explored quite a bit. And that is essentially planting trees back into our farmland spaces, planting trees into pastures, planting trees into row crop systems, and all the interactions and benefits that that affords. There's actually, that actually helps build resiliency into our farmlands. It helps diversify crops. It helps provide all kinds of soil health benefits. So looking at, you know, some of the systems where maybe we're not used to having trees, or we've sort of gotten rid of trees, and looking at reintroducing those trees again into some of these systems. Again, that's adding diversity. It's adding resiliency into those systems. This little graphic down here, I'll just talk about really quick because it is interesting. We have land use there, different land uses, and then what these bars represent is the ability of that land use to sequester carbon over the course of a year. And so grazing management, you know, the way that we manage our grazing lands can have a good benefit. Cropland management, if we are managing our croplands well, we can sequester carbon on those croplands. But we see agroforestry there. When we add trees back into our farming system, wow, we really have the potential to sequester some carbon. So kind of an interesting aspect on adding trees into a space where we've kind of gotten rid of them. So I'm wrapping it up to just recap really quick. So talked about how we're facing these changing trends in our climate. We've got some predictions, so we kind of know the trajectory that we're on. We're already facing some impacts. Many of us have witnessed some of these impacts, and we definitely have some predictions for further impacts. And how we respond to all this can be very overwhelming. So, you know, kind of keying into those areas where we can have a big effect, and really create that resiliency in our landscape. And we all have the power to do that, right? Through some actually very simple techniques. And I really just talked about two. I really just talked about two things: the soil, the power of that soil, and the power of trees. If you could even just focus on those two things in your landscape, you're going to have a massive impact, not only for climate change, not only for building resiliency into your own landscape, but if everyone starts doing it, or even if half of us start doing it, you're also creating this resiliency that kind of resounds out, and that has this ripple effect, right? Creating these wildlife corridors that Catherine mentioned, creating these sort of ecosystems that have benefits out into the community, out into the region, benefits for our own landscapes, for our own backyards, for our own pets, for our own livestock and crops and gardens, and even benefits for all the wildlife that we share this beautiful environment with. So that is what I have for you. Oh. This is my contact info. if anyone, you know, wants to contact me or wants to discuss or has questions, and I'll leave it open to questions.
I'm going to wait for questions, but there was a comment from Facebook that pollarding, coppicing, the pioneer species like red alder, increase its lifespan. Have you heard of that? I'm unfamiliar with that.
Yeah, so you can, some of these species like alder, like cottonwood, like poplars and things like that, you can coppice them, kind of cut them, and they'll regrow, right? They're species that will regrow. So you can cut them down, they will regrow. And so, yeah, that it kind of regenerates the growth of the tree. And so, yeah, it will over time increase its lifespan.
Interesting. One question here, the mature tree sequestration rates were very interesting, were really interesting. Do you remember the reference?
I can find it. It's Evergreen State College. It's a project that they did. So yeah, I can find that one and
Okay.
send it to whoever is interested there.
I will. I have the name right here, and we can send that to her.
Great.
Yeah. And we can, yeah, we'll just have to do that. And then anybody else who wants it, we will just email us or email Carrie, and she will be happy to get that information to you. I'm not seeing any other questions. Let's see. Okay. Nope. Okay. I want to thank everybody for attending our webinar this evening. Our hidden helper tonight is Carrie Brausieck, another member of our outreach team. She has a very cute cat there in her screen photo. Thank you very much, Carrie, for all of your fantastic information. Oh, wait a minute. Oh, and we got a thank you and a great presentation. So thank you very much, everyone. Again, if you have any questions, just let us know. Have a great evening.
Thank you.
Thanks.